Hi all, I am K. Surya, working as Assistant Professor in the Department of PCE at SNS College of Technology. So in this video, let us see about cloud computing for IoT data computing. So IoT data computing refers to the process of processing and analyzing the data that is generated by the IoT devices. So as we know, IoT devices such as sensors continuously generate the raw data. So however, this raw data alone is not useful unless it is processed and converted into meaningful information. So this processed information helps in decision making, automation, and intelligent system behavior. So, for example, consider a temperature sensor may continuously send the readings, but only after processing this data, we can detect the patterns like overheating or sudden temperature changes. So now let us understand about why cloud is needed for IoT data computing. So IoT systems generate data that is large in scale, continuous in nature, and often requires real-time processing. So traditional computing systems cannot efficiently handle such massive amount of data and fast data streams. So cloud computing provides high computational power and elastic resources, which means resources can be scaled up or down based on the demand. So this makes the cloud platform highly suitable for IoT data computing, especially in applications like smart cities, healthcare monitoring, and industrial automation. So next we'll see about the mind map for cloud computing paradigm. So here we will see about the IoT cloud architecture, application protocols, cloud service models, applications and challenges. Uh, so in the infrastructure, we will see about the sensors and actuators, access networks and edge devices. And in components, we'll see about the virtual resource pod, application servers, database devices, etc. Now let us see about the types of computing in IoT. So IoT computing can be broadly categorized into three types: edge computing, fog computing, and cloud computing. So in edge computing, data processing happens near the IoT devices itself. Uh, so this reduces the latency and it is useful for real-time applications. So in fog computing, processing is done at intermediate nodes, say such as gateways. So in cloud computing, processing happens in centralized uh, data centers, providing high computational power and strong capabilities. So each type has its own advantages, but cloud computing is widely used for large scale data analytics. So now let us move on to the cloud-based data processing models. So there are three main processing models here, so which is stream processing, batch processing, and hybrid processing. Uh, so stream processing involves continuous processing of uh, uh, incoming data in the real time. So it is low latency, meaning the delay between the data generation and processing is very small. And this is useful in applications where immediate response is required. So, for example, in a healthcare monitoring system, if a patient's heart rate suddenly increases, stream processing can trigger an alert instantly. So next one is batch processing. So here data is collected over a period of time and processed together as a group or a batch. So it is suitable for applications where real-time response is not required. So, for example, say analyzing an energy consumption data at the end of the day, or say generating monthly reports uses batch processing. It is efficient for handling large volumes of data, but does not provide instant results. So next, let us understand about the serverless computing for IoT. So serverless computing is a cloud computing model where the developers do not need to manage the servers. Instead, the cloud provider automatically handles resource allocation and scaling. So code is executed only when required, making it cost effective. So in IoT serverless computing, it is useful for handling event-driven tasks. So, for example, when a sensor detects an abnormal condition, a serverless function can automatically process the event and trigger an action. So, this reduces the operational complexity and improves the efficiency. So, cloud platforms provide powerful processing capabilities, scalability, and flexibility. So they support both real-time and batch processing. So they also enable advanced analytics, machine learning, and automation. So additionally, we can say that cloud computing reduces the need for expensive hardware and simplifies the system management. So hope you understood this. So let us take up some assessment questions. So why is cloud computing essential for IoT data computing? Yes, the answer is this provides powerful, scalable computing for IoT data. So next one is which processing modes are supported by the cloud-based IoT systems? The answer is both real-time and batch processing is supported. Thank you for watching this video.